So the next thing we're going to take a look at is sort of better design. And we're just going to sort of peek the door open at the concept of what object-oriented programming really gets to. Now, we could spend a lot of time talking about good object-oriented design, and by no means will this be an in-depth discussion about that. But basically, I'll just try to get across what the basics of it are to sort of make sense of how this is a better design in your game. So good object-oriented design doesn't usually start by talking about like Marios and stars and fireballs, paratroopa. That's usually the last thing in the conversation. Essentially what I'm getting at is we were talking about characters here, and we're talking about enemies here, we're talking about projectiles, and we're talking about power-ups. So the example that I'm going to do, I'm going to make a new class here. And this class isn't going to have a character with it, but it's going to be a power-up. Now, the star is a kind of power-up. So I'm going to go into the code now, and I'm going to change this. And instead of saying that it extends actor, this is the syntax in Java that tells Java who is the parent class, the class that it'll pull all the code from. And in this case, I want it to pull from Powerup. So every method that's in Powerup is now going to be available to the star, even though nothing's there yet. But you're going to see Greenfoot shift the class hierarchy around a bit here. So once this is compiled, you'll see the star now here is underneath the Powerup. And again, if you think about the design of your code, talking about those specific classes like stars and other things, they're important because eventually they happen. But if your game is built on what these higher level classes are, these power-ups or characters and projectiles, then your code's not affected by adding new ones. Because right now, if I want another power-up, Mario has to essentially be aware of it. Mario needs to know about all of the power-ups I'd want to add. Right now, his code contains the star class. You can see he has to be aware of it and what it does. In fact, he is doing the work of the star class here. And one typical code design thing that you want to strive for is that one change to your project doesn't populate everywhere else. So this is a change where adding the star class populated into the Mario class. He had to know about it. So that's what we're going to try to resolve here, and I'll show you one way of doing this. Okay, so we're going to switch back to the new class, the Powerup class, so we can talk about what kind of stuff happens there. And you want to talk about this in generality if you're going to be doing, or trying to do some good object-oriented design. Essentially here what I want to be able to say is, what do all power-ups do? Not just the star, but what should they be able to do? So one thing that I'm going to put in here is I'm going to say, you should be able to tell me how long this effect lasts. So I'm calling that the lifespan of this power-up. This one, I'm just going to return 0. There's other mechanisms, abstract classes if you want to Google them, that'll allow you to leave this blank, but let's just keep it simple. This power-up doesn't exist, so let's just say it's return 0. The other thing I need to do is I want to implement this power-up. So I want to change my character. And again, it would be even better if I had a class of characters, right? Like, most games you can choose who your character is going to be, that kind of thing. Then I could just plug in any character I wanted, not just Mario, because right now I'm being very specific and saying this is the class Mario that I use. But as it's kind of the first design one I'm talking about, I'll just say let's stick with Mario. So the only real object-oriented design I'm going to try to show you about is in the power-ups, and you'll see how that affects the code. And again, in this case, it's not going to do anything to Mario, but there's a placeholder there now that all power-ups have these two methods available. So now when I go to the star class, those are the things that I want to be able to communicate, is how long it lives and the effect it has on Mario. So Mario's not going to be able to get any changes happening right now because everything Mario has is a private variable. So that means no one outside of the Mario class can do anything about his fireball strength and all that other stuff that he has here. All these declarations of private are good because that hides it. So we're going to use the accessors and mutators that we had before. I can see in here some of his abilities, so I'm going to go and make accessors and mutators for each of them. You don't need to watch me do this, so I'm going to come back after I paste it in. Okay, so there's all the accessors and mutators that I put together, and again they just coincide with what these abilities can be changed to. So getting the speed, setting the speed, fireball distance, all that kind of stuff. The only thing I didn't do both for was the power-up counter. Basically, in this case, I don't see the need really to know if the power counter is active, because you can't really change a power up unless it's at 0 anyway. So anyway, that was my decision, but I made the method just one that if you begin the power up, you have to tell me how long it lives for. So this is where I'd say begin power up 50 instead of using the hard-coded example I've got right now. So now that these accessors and mutators are there, now I can go back and have the star do an operation on Mario. So let's go back and let's actually build what a star power-up is, and we'll connect it to its parent class, the Powerup. So remember, this is where we left the Powerup. Now my job is to say, okay, all Powerups have that ability. Let's now talk about what that ability is. So for the star, I'm going to say here public int lifespan, and oops, I'm going to return the 50 just like I had before. And change character. That's the other method. Here, maybe I'll split screen this just so you can see the two come to life. Here's the power up. So the star is a power up. It's building on it. So now I'm actually giving it a purpose when I change Mario. In my case, what I'm doing is changing the fireball strength. So I'm going to say m.set fireball strength, and we change it to 3. So these methods are there and they're available to use, but basically at this point I haven't connected them to Greenfoot, and that's what I'm going to add as my last piece here in the act method. And this is essentially the same sequence. That's why I've broken it down into those two things that all power-ups do. So I'm going to put it over here, and I'm going to say that when any power-up acts, this is what it does. First, we want to know if it's touching Mario. And if that's the case, then we can begin the sequence. And the sequence goes like this. We need to get that Mario. So I'm going to say Mario m equals, say, get one intersecting object from the Mario class. And remember, I've cast here because I had to get an object, but an object's not good enough because it wants a Mario. And since all objects aren't Marios, I have to say to Java, this is me making you aware that I know I'm making this cast and conversion into a Mario. Otherwise you'll get an error there. But now I'm actually holding on to, with this variable m, I'm actually holding on to the Mario that I wanted to, or I guess that I'm touching right now, that the power up is touching. And in here, I'm just going to say now m.begin power up, and it will be for whatever lifespan you have. And the beauty of the object-oriented design is it knows which class is doing this. It's going to hop down to whoever it is that actually called upon it. So if it's the star that's touching Mario, it's actually going to return 50. So it actually dynamically resolves whose lifespan it's going to be. And then again, the other thing I'm going to do is say change character, and m is the character that I'm changing. Again, it'll hand it off at runtime to the proper power-up, the one I've defined over here. So at the moment, the star class has its own act method, which means it won't do what the Powerup class does, its parent. So one quick and easy way to resolve that is just get rid of it. When it's not there, that means it goes back here and it defaults to saying, okay, if I don't have it, then use whichever parent method I have there. And that could be several ways up the chain. It could be a few classes before it finds the method. The other way you can do it is more explicitly. You can go in here and say super.act. That's how you reference the super class. That's the super class there. So you say go up and ask them to act for me. So both ways are fine here, but that's the sequence it would go through. Is now that it's touching it, it will apply the power up to it, and then we're going to say remove the one that, well, this object. So I'm going to say get world and remove object, and this is another keyword in Java, this. Remove this object from the game. So this refers to whichever object is currently executing the code. Remember to be careful about where you ask for get world, because if you've removed yourself, you can't do this anymore. But I believe this is a safe call so far. So now that the stars know how they do their own power-up and the power-ups handle all that stuff themselves, I don't actually need Mario to worry about it. All Mario needs to know is that sometimes he's got a power-up, and when it's over, he's going to reset his abilities back to the default. The stars don't know what that default ability is. So all Mario is doing is saying, well, if for some reason I've got a power-up happening, then let's just keep counting it down until it runs out, and this method will reset it the way it's supposed to go at the end. So there's, again, no new net result to the code here. It's a different way of doing the same process. But the advantage is, and I'll show you this, how quickly I can add new power-ups to the game. So it was a little bit heavier at the beginning because we had to add some accessors and mutators here, ways that other things could interact with Mario. But now that that's there, and I've developed my hierarchy here, where I've now introduced this concept of a power-up instead of the specific class, the star, now it's really, really fast for me to add extra features. So just briefly, now that it's compiled, I'll show you again that it does still do the same behavior as before. So Mario right now, his power-up strength, or fireball strength, is 1. And if I go and pick up that star, now you notice it disappeared because it knows that's what all power-ups do once they get touched. Now its fireball strength is 3. So what I'm going to do real quick then is I'm going to add another power-up to the game, and truthfully I didn't actually remember to go and get a good image for it, so whatever, we'll just use any, we'll just put in a new one. I'm going to call this a Speedup. Let's see here. How about a food? We got a decent food here that Mario would eat. How about an apple? So again, now that this is a power-up, it has to either use what its parent does. So let's line them back up again so we can see. It's automatically going to get the code over here on the left side of the screen, and it does everything a power-up does. But a power-up doesn't do a whole lot here because it's this generic top placeholder class. It speaks for all the power-ups unless the power-ups speak up for themselves. So that's what I'm going to do here. So I'm going to say, you know what I'm going to do is make my own lifespan, because this one here is a lifespan of 0. So we'll go lifespan, and I don't know, just for fun we'll return 100 this time. And now when I want to change the character, I'm going to affect how fast he goes. So rather than hard code a number, I'll make use of it like this, as I'll say Mario set his speed to be Mario get your speed +1. Now this is going to be a little bit harder to see on the screen, so for now I'm going to make it +5 just so you can visually see the effect come in a lot quicker. But notice that's all I did. I added a new power-up. No one else in my code needs to know about this class. So again, that's an aspect of good design, because I don't have to update anyone else. I get to put it in, and I don't have to, it doesn't ripple through my code. It is independent the way it's put in there, and it's going to play nicely with the other classes. You might have noticed I just typed that super.act in there, again, because I do actually want to obey the generic version of what all power-ups do. Maybe this time I'll get rid of it just to show you that it does actually use the same code if you omit it. So again, no new net difference, but I'm going to be able to show you my Speedup power-up in those 30 seconds it took me to write that code. Okay, so I'm going to add the Speedup to the world. This one I don't need to inspect for you. You'll actually be able to see it the minute he touches it. So now when he runs, boom, he's going quickly, and it's those 100 acts will be over, and at some point here, maybe, oh, there he goes, he's back to normal speed. But again, what I want you to appreciate is that the second power-up I put in, once I built the infrastructure, I can add whatever power-ups I want now. And this is all I needed to write, just what it does to Mario and how long it lasts for. And then I can keep designing new ones with really, really quick and easy additions to my game. So the same principles would apply to enemies, right? What are all the common things that enemies do? Paratroopa is one of those. So then Paratroopa can build on its own specific ones. But if every enemy I add to the game, That way my code is a lot less, and I can leverage that object-oriented design. Projectiles are super common too because they share a lot of the same behavior, like the way they move. They just keep moving in the direction they're facing. Some have different speeds, maybe different damages, but we can add that into the code of what a projectile class would be. Other things, like all projectiles probably are going to remove themselves when they hit the edge of the world. You don't need to code that in every one of the projectiles. You just have the one parent class, like this one, and it will speak for all of them unless they decide to change it. So at this point, all I'm going to say is you should add at least one hierarchy just to show me that you understand the example that I gave you. But if you really want to work with the principle, you should try and add some more. And of course, ask for some feedback in the lab from me, and we can work out some real effective uses of that.